Hello dear friends, welcome back to my channel. I'm Gerard and I'm here to study math together with you. I'm revising my pure math since I am now doing my BSc physics with mathematics as an elective. So right now I'm still learning about quadratic equations. So today we're going to look at some complex uh, quadratic equations. So that's what we're going to look at. So we know very well now how to solve a quadratic equation, ax squared plus b plus c. This is a normal form. We have seen what's completing the square. We know how to complete the square if this cannot be factorized. We know that we can factorizing. So we can factorize to have the set of solutions for this, or if it's not, we can use completing the square, or we can also use the famous quadratic formula. So this is an expression. It can be an inequality, for example, or it can be an equation. So that's what we have learned so far. And because we are going to deal with what we call complex quadratic, so it's going to be slightly more difficult. And instead of having x to the power of 2, we're going to have x to the power of 4. So let's look at an example. So an example is x to the power of 4 minus 5, x to the power of 2 plus 4 is equal to 0. So if you want to solve this problem, it's going to be quite hard, especially because of this. So if we had only this, it would have been much easier. But let's see how we should do this. So let's say y is equal to x to the power of not 4 but 2. So which gives us what we know, what we're used to, which will give us something like 5y therefore plus 4. So now we have something that we are used to just by making substitution. This is a method to solve this complex quadratic equation. And so I just did something with my notes. Just pause. Okay, so here we are. So how do we solve this? First we can try to factorize. Yeah, so let's look, how can we have a times b is equal to 4, or a plus b is equal to minus 5? How can we do this? So if we have minus 1 times minus 4, it will give us 4, and if you add these two, it's going to give you minus 5. So I think it's possible to factorize it, so then it should not be so difficult. We have minus 1 minus 4. It's not perfectly squared, it's not like this, it's not a perfect square. Whoops. So we have obtained this, and since it's an equation, it's not an inequality, we can also not draw the curve and so on. And actually I don't know how to to draw this, I think it should also be like this, you know, somewhere like that. I don't know how, but I cannot draw it right now. So let's solve this problem. So we have y is equal to 1 and y is equal to 4. But since we use this, so y is equal to x. So we have x squared is equal to 1 and we have x squared is equal to 4. When we want the value of x, we have plus or minus root of 1, and we have plus or minus root of 4. It will give you 2 here, so plus or minus 2, plus or minus 1. So these are the solution sets for this. So just for fun, or just for more knowledge, what we can try to do is try to understand how it looks graphically. So if we have 0 here, this is x, this is y, so we want to see, so minus 1 here, 1 is here, we have 4 here, we have minus 4 here. So we have x is equal to 4 and no, x to the power 4, sorry. So what we have is something that might be like that. I don't know, might be something like that, you know, might be a graph like this, or it might be like that also. Wait, here, up, down, down, up, I don't know, something is, oh, okay, here, there, okay, here, you can have like this. Okay, either way, I don't know, this is how it looks. You can plot some points, you can try to, but definitely these are coordinates that touches the x-axis, yes. So I hope this video was useful to understand so far how to solve complex quadratic equation by substituting, and so it can help you to get more results. And well, sometimes it's going not to be just for an example. Let's say if you have something awful like this, you have to solve it as a quadratic equation. So here it looks very complicated, you know, how to turn this to something like that. So what we know is that that's really interesting. That's very interesting. Should we say y is equal to x4 here? So then if we have y to the power of 2, we actually have x4 to the power of 2, which is, no, this is 8, so it's not good. So we need 3 and 2 then. 2 is good. 2 is good. So 2 is good. 2 is good. We can have y is above 2. is equal to x to the power 3. So if you want this to be x to the power of 6, then you will put this here, x to the power 4, y to the power 4. I'm a little bit lost. Let me just pause this and I will come. Okay, so I have come to this, which will yield this, which is a quadratic equation that we can solve. We're used to, and we have a, which is 3 here, and we should not waste time with this because we can send this here. Okay, I have a low battery. 3yx minus 47y minus 2 is equal to 0, and we can try to complete the square and so on, but it looks so complicated that I would just advise to use the formula. You can just use the formula and get things done. So just use a formula, guys, when it's needed. So minus b plus or minus root square b square minus 4ac divided by 2a is equal to 0. So no, it's equal to x, sorry, not 0. And what we need is, so it's going to be 7 plus or minus root of b squared. 49 minus 4. 4 times a. It's 12. 12 times minus 2. So sorry, 4 times 3 times minus 2. That's what we're talking about. So it's going to be minus, so here it's going to be plus, and it's just 12 times 2, 24. 24. And here 24. Guys, I need to write like this, it's much easier. And so this is done. 2a now, 2a. 2 times a. I forgot, a was 3, sorry. Times a, 3. So we have 7 plus or minus, plus here. 49 plus 24 gives us 13, yeah, and 6, 7. 73 divided by 6. So that's what we have. That's what we have. We have 7 plus root 73 divided by 6, and x is equal to 7 minus 73 divided by 6. So I can use a calculator and check my answers. So here I have 2.59. It says to 3 significant figures. So this is the answer. Let me try the other one. So it's 73 root, and then I haven't been using this calculator for a long time, so I need to make it minus. Okay, here. Woo. Plus 7, integral this, divided by 6. And the other one is minus 0 to 5, 7. So I will pause, look for the answer, and I will come back to you. Thank you. So guys, I have checked my answers and they are not correct, and that's because I think we are still not done here. If you remember, we use this y is equal to x to the power 3. So this is y, and we want x. So we have to have x, we need to have the cubic root of y. So you see, this is, yes, and then it's good, and only then it's good. So yeah, so this is also a mistake that you might make when you are working with such a complex quadratic thing. And yeah, the other one, I was not successful with the second root. Let me just retry it. So we have 73 root of 73, 73 root. Change the sign, and I plus 7, and I divide by 6. Yes, I got this. Now I have to find the root, cubic root of it, and yeah, now it's good. Now it's good. Alright guys, please do not forget to do this. If you use this, you have to do this at the end. But this was so helpful because we got something like this to deal with, and we use this formula to get things done, and here you are. I'm quite happy because, you know, I'm even able to find my mistakes at this level, so this is very positive. So we're going to continue in a very how to say, in a very near future with quadratic equations, and we're going to see the discriminates and how it affects the shape of the curves. So thank you for watching and enjoy the rest of your day. Cheers, bye.